So hi everyone, my name is Sibeli. I'm here today representing the Brazilian team, and I'm going to introduce you to the Curupira Biofoundry, a Brazilian perspective of biofoundry usage for biotech. A bit of the context of our project, you may not know, but Brazil is the most biological diverse country in the world. We host around 20% of the world's biological diversity, and we're home to 70% of the world's cataloged animal and plant species. We are also a northway for biotechnology industry. We are responsible for 30% of the global fuel ethanol production, and we have the largest agricultural producer in several sectors, and we are on the top 3 producers of several different commodities. And well, when thinking about the Brazilian biofoundry, we see the potential of accelerating the creation of new products based on the regional diversity. We would both address the local problems, increasing the life quality of small communities, but also address global problems, assisting humanity on the transition to a sustainable society. And that is exactly what we have in mind on our goals. We want to reconcile biodiversity richness with the industry interest. So we would really discover and improve microorganisms and think on an industry setting where we really improve the efficiency of industrial microorganisms, thinking about bioproduction. And when trying to see a suitable biofoundry process, we had a few criteria to evaluate what would fit best on the Brazilian context. And well, in Brazil, we have a lot of opportunity in terms of strains for industrial use. When we think about using these criteria and having the Brazilian scenario in mind, we saw that other biotechnological methods, such as bioprospection and artificial selection, will be a better fit than synthetic biology. And here comes our opportunity here. Brazil possesses more than 3,000 cataloged species of algae, and we have an extensive tropical coastal area and sunlight disposability all year. We have opportunities for the development of a sustainable microalgae-based industry, and we decided to improve these microorganisms for industrial usage as a first good prototype. Also, taking into consideration the legal ecosystem here, we have the Brazilian biodiversity law that generates royalties from products developed from our biodiversity to the indigenous population related to them. And here you can see a bit of an overview of our process, really integrating the design, build, and test cycle from the bioprospection to finding the best first strain until finding our suitable candidates. And when talking about the strain development process, we have 2 fronts. The first one is breeding, and the other one is UV mutagenesis, where we would apply both these processes and really identify the best strains based both on growth and also specific characteristics that may be interesting for us, and repeat this cycle until we find the best candidate. And well, we are talking about biofoundry, so an important thing when talking about a strain development process is the automation. So we would use open-turn robots for the sequencing and automation of the whole development process, and also implementing the UV lights for the induced mutagenesis and doing all the quantification for OD to really see the best candidates related to growth. And well, here you can see a few of our milestones. We think initially of an 8-month implementation process that would go from identifying cultivation methods, seeing the best approaches for quantification, until several cycles of automation until we have the best final candidates for strain. And well, this is all for now for the Curupira Biofoundry. Thank you so much.